We got a lot of people got programs turned in last week. That's super. I mean, I had people coming to class, Wednesday, Thursday, Friday last week, and working on programs and getting caught up on some. So a lot of people raised their grade last week, just getting extra stuff turned in. As far as last week's program, there's still a lot of people that haven't done that in here. See a lot of people missing. I see several people have got it turned in, and I haven't graded it yet. So I'll be getting to that as soon as I can. I tried to get everything caught up on Friday as far as grading programs, but I may have missed a couple because there was a lot turned in last week. A lot of programs, a lot of older programs. So I was having to go back to the older templates and grade those. But there was a lot done, and some of them I've got graded, and I made some videos for you guys as feedback and haven't got them to you yet because I ran out of time last week. But we'll get there. We'll get there at some point. But anyway, so yeah, welcome. We're still waiting on a few more folks to wake up and find their way to our classroom. So we'll be in good shape. This week we do not have a program, so that's nice for you folks that don't have last week's done yet. You got more time this week because we don't have a program to write this week. We just have our usual 5-question quiz on the off weeks. We will have a program next week, which will take us into spring break. So this week, next week, and then spring break week. So we're right there at that turning point of the semester because after that, it's just all downhill. So I need to look ahead here for you folks that are behind, and as the semester moves on, don't keep being behind. We've got a program next week. Trying to look ahead and see how many we have next unit. Let's see what that is. Okay, we'll have one at 6.01. We'll have one to start the next unit. Now we'll have right after spring break, we'll have the exam over this unit we just did with all the number systems, ASCII, binary, all this other stuff. What we're going to study this week and next week's program. We'll have an exam, so we won't have a program to write after spring break. It'll just be a common exam. We will have a program to start the next unit. And let me look ahead beyond that. That may be our last one. Oh, wait. Let's check at that. Nope, that'll be another program. So there's at least 2 programs in the next unit that we will have in April. But we will not have any programs to write in May. So you folks are behind. Just keep working to get caught up, but you don't want to write 4 programs in May because that will be chaos and you'll be just scrambling trying to get stuff done. You'll have a lot of things wrong. You'll be missing a lot of stuff and your grade will not be good. But yeah, what we got looks like 3 more programs total, I think, for the semester. So that's there's light at the end of the tunnel, folks. For you that are behind. So, all right, I believe that's about it. Okay, take a good look at that. I think that's about where we're at. So, all right, cameras on for those of you who are still half asleep, got one eye open. Go ahead and turn your camera on so we can see you're here. Oh yeah, a lot of people got stuff turned in over the weekend. I see you got a lot to grade. That's good. That's good. Yeah, that was empty on Friday, pretty close to it anyway. Let me pull this up so I can get our lesson up for the week. Let's take a look at what we're going to do. All right, programming. Let's go to our grade screen as usual. Best place to start each week to see what you have, what are you missing, what you got turned in. Oh, look, I've got my program turned in, and even my program is not graded yet, but I got mine turned in, decoding ASCII. So that's what you should have had last week. And this program last week is actually very simple because they gave it to us in the lesson. Almost everything you need. We'll look at 5.03 today. I will look at last week's lesson real quick for those of you who haven't done the assignment yet, hadn't written the program. I had a lot of people come in last Wednesday, Thursday, Friday, and they were asking questions about this program. And I said, well, the lesson basically did it for you. You're supposed to take a quote, encode it into ASCII, and then take the ASCII that you just encoded and decode it back to a quote. And I said on page 5, the last slide takes a quote and makes an empty list and encodes it into ASCII and prints the ASCII code. I'm like, that's half of what we're supposed to do. And then slide 3 took the ASCII, which we just created. So we don't have to type all these ASCII numbers. We just created that. But they created an empty message and then decode the ASCII and print that. And that's exactly what our program is supposed to do. It's supposed to encode this into ASCII and then take the ASCII and decode it back into a message. And the nice thing is it saves the ASCII for you right here in code message. So all you got to do is decode code message because it's already there for you. So it was right there in our lesson for us last week, and a lot of people don't have it done. All right, 5.03, procedural and object-oriented programming, which we call OOP. So programming design approaches. So let's talk about vehicles here. There's a little illustration of many vehicles. The colors are changing on them. Sedans, SUVs, a coupe, hatchback, sports cars, pickups, camper vans, micro electric cars, four-wheel drives, all kinds of different vehicles. They're all vehicles, right? They're just different. They've got wheels, they've got doors, brakes, tail lights, air conditioning if you're lucky, which generally around here most cars have air conditioning. Each of these pieces make up a vehicle, but they have different features, like some different colors. Some have more specific uses, like pickups, mini trucks, or I wouldn't recommend off-roading in your smart car. But some of these are definitely designed for that, but they're all considered vehicles. They're just different things. Vehicle manufacturers could create each one from scratch. Let's make another car. Let's see, get some wheels, decide the color, size, and engine type individually, or they could create a template and mass produce them, which is how most of our vehicles are made in this country. The assembly line, thanks to Mr. Ford, who figured that out over 100 years ago. We can make it cheaper by just building an assembly line and making car after car after car after car after car. So just tweaking certain parts for variety, paint them different colors. But some of them have electric windows, some of them have roll-down windows. You can vary those things, but for the most part, on an assembly line. So what about airplanes or rocket ships and horse-drawn buggies? Well, those are also vehicles. So what do they all have in common? Well, they all transport things. They require a driver, which is becoming less and less true these days too, because a lot of them don't need a driver, right? They go to and fro. A lot of them go fro. Remember how we were talking vehicles? I'm really talking about program designs approaches, really. Program design approaches. We're going to, after this lesson, be able to define procedural and object-oriented programming. We're going to compare procedural and object-oriented programming, and we're going to discuss the advantages of using object-oriented programming. So let's get to page 2 here. Procedural versus object-oriented programming. So the term design approach refers to the way a programmer thinks about his or her code. This choice of approach can vary by project or by programming language. Maybe with different languages, you're going to use a different approach. But there's 2 main design approaches used in programming. First is procedural programming. This is a programming design approach that divides well-defined tasks into modules, functions, or procedures. So when you're learning the program, you often start with just a high-level description of what you want your program to do, and then you break it down step by step into the functions needed to complete your actions. And that's kind of how we've done several of our programs. It's like if we're going to take something and encode it into ASCII and then decode it, we step by step. What do we need first? First, we need a quote that we're going to use to decode something or encode something. Then we need a place to store our ASCII, so we create a list. Then we actually have the loop and encode each letter into ASCII. Then we print that. Then we take that ASCII that we just created and we run it through a loop and store it decoded in another variable. Step by step, how do we need to make it work? So you do this when you write programmer-defined functions. because we created our own function. Usually we use the main function, right? Define main, but we did back in December actually define some other functions, and some of you use that in some of your turtle functions that we did in the last month. So you take it one step at a time, first deciding what your function is going to do, then what are we going to name it, and how's it going to work. Then as you go, you write the code needed to execute it. So manufacturing vehicles from scratch would be a lot like procedural programming. It's got a roll. We need an engine. We need seats. The other design approach, other than procedural programming, is called object-oriented programming, OOP. This is a programming design approach that focuses on objects rather than functions, often referred to as OOP. In OOP, the programmer thinks in terms of objects, which is an instance of a class that encapsulates its own attributes and behaviors. So rather than using functions, objects are designed using a class and are parts of a program that can carry out certain actions and interact with each other. So manufacturing vehicles from a template is similar to OOP. So let's take a look at some of the differences. In procedural programming, let's have a description of both. An approach to programming that uses a list of functions or procedures that tells the computer what to do step by step. With OOP, it's an approach to programming that uses objects to carry out different functions. Let's look at the application. This is known as top-down design on the left, procedural programming. Programmers will start at the beginning and work through every step, whereas OOP, it uses classes to define and create objects for a programmer. Programmers write code and have objects interact and perform actions. Languages. Early programming languages like Fortran, COBOL, C, and BASIC are mostly procedural. BASIC is the first language I learned to program in. Most of today's newer languages like Python, Java, and C++ are object-oriented. So we're using more of object-oriented when we do a lot of the Python stuff. An example. You're planning a party the procedural way, you'd list all the steps, send invitations, buy food, decorate, make a list, prepare games. The OOP way, we would call party planner, which was a function we created that does all of that. And that's the one that we used for our last party. We'll just have it do everything we need again this time. Yay. So you have predefined things that you already used before and you reuse them with OOP type programming. So while procedural programming is a logical way to think about writing code, object-oriented programming is also pretty intuitive. Once you define a class, it's easier and easier to create new objects. However, OOP does require more planning up front because more objects can mean more complex programs. Let's dig into some of the nitty-gritty of OOP. Vocabulary. So most things you encounter daily are objects, like cars, furniture, your phone. And for each object, you can customize the way it looks. Most of you guys' phones probably look very different than everyone else's phones. Different cases, different stickers, different whatever you do to your phone. You can customize the way it looks. It's different features and what it can do. And we define objects by their different attributes and behaviors. These real-life objects can be simulated with program code. So let's look at this image to learn about important technology related to object-oriented programming. Okay, so here's someone's phone. And if we look at the different features, let's start at this top plus right here. The class. This refers to a template used to create new objects. So think of it like a blueprint that has existing characteristics you can use when creating new but similar objects. So every time you create a new contact on your phone, it uses the contact class. So we're talking about a template. We can consider the class a template. So when you want a new contact, it's already got all of these fields. You just have to fill it in and make it unique. So it's not exactly like another contact, right? It's got a different name or a different number or all kinds of stuff along that lines. So, but the class is the contact template. An instance, many instances of a class can be created. An object is an instance of a class. So each individual contact is an instance of that class. One individual contact in your phone is an instance of a contact object, right? So you have the contact and each one is an instance of it. Over here is a little add photo button. This refers to the code that allows you to create a new object, constructor. It's a special method used when a new instance of a class is created. The initial values are set, and this is like adding or constructing new contacts in your phone. Over here, we've got initializing. This refers to what the constructor will do when you use it to create a new object. It will initialize the object in the program. When you create a new contract, all of the attributes will have initial values. A lot of them will be blank already, but this has like company in gray just to know what you can put there. So there's these initial values. Some of this may be initial values. The ringtone may automatically be, default on the vibration or not. These are initial values that you can change if you don't want them to be that for this specific contact. Here's where the phone number is. These are the attributes. These are the features of this specific object. The attributes of a contact might include a phone number, an email address, or a picture. And attributes are often nouns and adjectives that define the properties or characteristics of the object. And then we have down here the behaviors. This is like known as the methods. For this contact, what is supposed to happen? So a specific ringtone refers to the actions that this object performs. You can set specific ringtones or vibration patterns to a specific contact. So when that person calls, a specific behavior is performed that's different than a different contact. So putting it in a phone version is kind of looking at how object-oriented program functions. Programming Spotlight, Mark Zuckerberg, perhaps you've heard of him. Born in 1984, least likely to succeed. He dropped out of college his sophomore year when he was 19 years old. It would seem that Zuckerberg was not likely to succeed, but we all know that's not true. He's a billionaire now. The Facebook co-founder began programming at age 12 and was a billionaire by age 23. The Facebook interfaces make full use of object-oriented programming, using classes to make new objects, including new user profiles, React buttons, notification features. Those are all object-oriented programming, and it's just a template that's used over and over and over again. Page 4. Advantages of OOP. So there's a lot of advantages. So there's a reason it's the way that most programming has evolved today. So let's check out some of the benefits. Reusable code. So once you write a useful class for one programming project, you can often reuse that class in another program instead of starting from scratch. Like if you create a class for a deck of cards, then you can reuse it for any program that needs a deck of cards. If you're going to create a solitaire program or a Go Fish program, if you've created a class already that creates a deck of cards, you just copy that into your new program and you're ready to go. Inherited traits. Programmers can use new objects that inherit traits from existing classes. This means they can add new features to an object without having to recreate it from scratch, just saving tons of time and effort. So, example, if you create a vehicle class that has all the basic functionality of a vehicle, it moves, it carries people or things, it starts, it stops, you could build on that class to create more specific types of vehicles like convertibles, bicycles, semi-truck. Flexibility. So programs created using OOP are easier to develop because of their flexibility. Objects can be used in a variety of ways and have different behaviors for different purposes depending on the program. If you create a class for your bank account, there's many bits of information needed, your name, social security number, birth date, to open the account or to get a loan. But for simple transactions, just like making a deposit, only basic information is needed, like your name and account number. So your bank account class can work for all of these. It can have that social security number and birth date, but it doesn't have to use it when you're making a deposit. And easy to maintain. Object-oriented programs are written modularly in sections, in objects, making them easier to maintain and understand once developed. So if you're planning a meal and you burn the cupcakes, you only have to fix the cupcakes. You don't have to recook the whole meal, right? So in OOP, objects can be maintained separately, making finding and fixing problems much easier. Oh, the problem's up here when I create the deck of cards. That's not working correctly. So I know where to go in my program to try to fix that. So that's the type of thing we're looking at. All right. That is the lesson on object-oriented programming. Next week, we will have a program where we're creating classes and objects next week. So we will have a fun program to write then. So you want to get caught up before you have to dig into that one. Let's look at our assignment. Defining a class in programming code is similar to writing a template, true or false. In object-oriented programming, what are attributes? So you may need to answer some of these, save and exit, and go back and look in the lesson if you didn't catch it the first time. In object-oriented programming, what is initializing? Which one of these? How are procedural and object programming approaches similar? What's one benefit of using OOP? So if you need to answer some and then you're not sure, save and exit. Save and exit down at the bottom. It'll save the answers you've already answered. Go back and check the lesson. Say, oh, I don't remember that. So these 5-question quizzes, let me see. This one has, well, it doesn't tell me how many attempts I have. I think it should be 3 attempts. So you can redo it if you didn't do well the first time. But next week, we will have a program to write, and then we're going to define a class. If I remember correctly, it's a superhero program where we create a class for a superhero, like a template, and then we can create multiple superheroes using that template. And you're going to write like a superhero story with him and the villain and that kind of thing in our program next week. If that's not next week, it's coming up in the future weeks because we have that one coming up. I think it's this one next week, but we'll see. So you can be thinking about your superhero story and what kind of superhero you're going to create. And like I've created Math Man in the past, and you can have all kinds of fun with that. But anyway, since you just have the 5-question quiz, this is a great week to get caught up on the programs, especially if you didn't get last week's program. Like I said, if you go to 5.02, page 5, slides 3 and 4, that pretty much provides you every command you need to write the program. You just got to put them in the right order, and you got to come up with your own quote. Don't use the quote in the lesson, but it practically writes the program for you. So most of these lessons, when we have a program, the lessons will give you the commands that we're using. Not always everything like it did last week. Last week it gave us everything. It just broke it up into 2 different programs. But it usually gives you enough to where with the previous stuff we've learned in programming, you can add the new code that we learn each week and write the program on that. So that's what next week's going to be. It's going to be using some of the past skills we got. And I don't remember it doing the entire program for us like last week's, but it'll do enough to teach us how to create a superhero template and that kind of good stuff. So, all right. If you have questions, if you're still struggling with something, we've got about 15, 20 minutes before cybersecurity starts. So this is a great time to bring that up. I'm happy to go over any programs you're struggling with, any questions you got on any of the programs that we've had due so that you can succeed and get stuff turned in, because there's still a lot of people that are missing programs here and there. We're almost to spring break. Let's see, this week is actually halfway through the semester because this is the first 9 weeks of the second semester. So that ends this Friday, and then we just got 9 weeks left. So, all right. So if you don't have questions, I'll let you go get started on this. 5 questions should be pretty simple for you. But if you have questions, bring them up now. Hang around. Let's talk. Let's go over what you're struggling with. So, but have a great week, guys.